This question is about esters including biodiesel. An ester is formed by the reaction of an acid anhydride with ethanol. Complete the equation showing clearly the structure of the ester. So let's have a look. This part of our acid anhydride will go into our ester with up to the oxygen of our alcohol, because the lone pair on this oxygen is going to attack the delta plus C. So I'm going to copy CH3, CH2, C double bond O. And then we're going to join it to the O of our ethanol, like that. And we're going to be left over with everything that wasn't highlighted, so another CH3, CH2, C double bond O, and then the O with the H from the alcohol joining on. Name of this ester. So the longest carbon chain containing the functional group is 3, so prop, no double bonds, and it's an ester, O8. And then we've got an ethyl group stuck on, so ethyl propanoate. In a reaction to form biodiesel, so this is the methyl ester of a long chain carboxylic acid from the vegetable oil. 2 moles of an ester with this molecular formula and 1 mole of an ester with this molecular formula. So remembering that our ester goes RC double bond O, OCH3, because it's a methyl ester. It wants us to represent the R part just like this, CXHY. So we need to kind of work that out. So C19H34O2, we're going to subtract 2 C's, we're going to subtract 2 O's, and we're going to subtract 3 H's to see what our R group is left out like. So we're going to get 17, 31. We've got 2 of those. Then our other one, C19H36O2, we're going to subtract the same, C17H33, that's our other R group, and then we have to draw the structure of the vegetable oil. So the vegetable oil is a triglyceride, so we've got our glycerol part of our molecule here. It loses the hydrogen when it forms the triester, the triglyceride. So there's the glycerol without the, and then we're going to join it to the C double bond O, and then we're going to put our chains on. So we've got 2 that are 17 and 31, and 1, I'm going to make that double bond go down just for space, that is 17 and 33. The compound C19H34O2 is the methyl ester of ZZ, so same side, octadecan 9-enoic, 9,12-dienoic acid. So we need to show the Z chemistry. So this is number 9. So if my double bond were to come down from number 9, like this, then the next bit would have to come off on the same side. So 10. This would be 11, then carry on the zigzag, 12. And we want another double bond at 12. So the zigzag would carry on this way, and then we'd have a double bond, and we want it to be Z again, so we come down this way, and it says to stop at 14, so I can just stop here. So they both need to be Z, so coming off the same side, the groups, the highest priority groups coming off the same side. Combustion is reaction with oxygen. Complete combustion means carbon dioxide and water are formed. So 19 C's, 19 CO2s, 34 H's, 17 H2O's. So 19 times 2 is 38. Add the 17, 48, 53, and then divide by 2. So either write 53 over 2 or 26.5. Combustion of biodiesel produces greenhouse gases such as carbon dioxide, which cause global warming. Part of the infrared of CO2 is shown. State how is not what you might predict. So in the data booklet, C double bond O is 1680 to 1750. If we look in table A. Our absorption is, this is 2200, this is 2400. So absorption at 2,350 centimetres to the -1 rather than 1680 to 1750 centimetres -1, which is where table A says C double bond O should be. Explain how carbon dioxide causes global warming. So it's all about the bonds. The C double bond O bonds in CO2 absorb infrared. We know that. We can see them in the data table. Okay, so they're absorbing that. The bonds vibrate. And then this energy is transferred to other molecules trapping it in the atmosphere.